Hello and welcome to Down the Well with Gravwell, where we explore use cases and scenarios that readily apply to real-world security analysis. This video is a continuation of the Triage series, which covered our initial alert and follow-on triage. In this series, we are going to investigate our environment based on indicators uncovered in our initial analysis. Don't worry, we'll refresh you on those initial findings. Using Gravwell, we will explore our data and conduct our investigation as we try to understand the extent of our organization's potential compromise. We will be using data from KC7. A link can be found in this video's description. The data in KC7 was built by cybersecurity experts to simulate real adversaries. Therefore, it is synthetic but realistic. Since it was designed for educational use, we're going to use this data in this video in order to make it easily consumable by a broad set of users. First, let's load up the Gravwell Query Studio. We have pre-populated the various tabs with the queries we will showcase today for the sake of brevity. In the previous series, Triage, we left off with a single host likely compromised by a threat actor who had gained initial access after a user clicked a link, downloaded a file, and opened it. Once we determined that the file had been downloaded by querying our file creation data, we pivoted to our process events to see if anything executed on this user's machine after our suspect files were created, to see if we could find any evidence of threat actor activity. What we found appeared to be attempts to orient within an unknown environment using the whoami command, and the invocation of an executable logolo.exe, which we believe is used to create a tunnel back to an attacker-controlled server. We are diligent analysts, and that IP address, 166.135.152.181, that was passed to the Logolo executable we observe, deserves some follow-up. Let's see if any other machines in our environment had process events that contain this IP. It looks like another host, NZ6J laptop, and our environment is SSHing to that IP, and once again, the parent process is our suspect, infector.exe, but with a different SHA-256 hash. We should also note that this SSH activity precedes the hands-on keyboard intrusion that we found on our initial victim for a HX desktop by more than 24 hours. That begs the question, did anything else happen on this newly discovered machine? We can see our malicious binary, infector.exe, initiates a ping with a target of 8.8.8.8, which we know is one of Google's DNS servers. This is a very common way for malware to check if it has internet connectivity. Good to know this binary cares about network connectivity, and this matches our expectations from our initial findings of an SSH connection 25 minutes later. From our previous triage efforts, we should recognize that the machine NZ6J laptop was not seen in our initial investigation, with 4AHX desktop being the only known victim at that time. Therefore, we should dig into how infector.exe ended up on it. Let's pivot back to the machine's file creation events data to see if we can determine how the malicious binary was delivered. 40 seconds prior to infector.exe being created, we observe a curious zip file that was created with the name itpasswordresettool.zip. This is starkly different from the file we saw during our triage, which was named criticalsecuritypatch.docx. However, the theme of IT and security combined with a sense of urgency, which are classic hallmarks of a social engineering facilitated attack, leads us to believe that this file may be related to our overall investigation. Can we determine where itpasswordresettool.zip came from? It looks like we have an HTTP GET request for a file matching the name itpasswordresettool.zip from an internal IP 192.168.0.40. We also see a second HTTP request, this time a POST request. from what appears to be an iPhone on our guest network with an IP of 192.168.2.79. And we know that NZ6J Laptop first saw IT password reset tool zip file around 2022-01-08 at 6:46. Thus, we can make a reasonable guess that this outbound browsing data is from that host. Let's quickly verify. And as we had guessed, the outbound browsing activity we observed from 192.168.0.40 does correlate to the hostname NZ6J Laptop, which belongs to Drew Mulinix at evolvelabs.com. We saw in our outbound browsing data that the file IT password reset tool was hosted on two different domains, updatesoftware.com and security.info. Since our previously known intrusion came via email, let's check that data source for any messages containing either of these domains. Immediately, we see an email message that was successfully delivered to Drew Mulinix at evolvelabs.com, which contained a link to updatesoftware.com, pointing to the file itpasswordresettool.zip. We can also see that this domain hosted another payload with the name importantinstructions.pptx, which will provide our hunt team additional information to pivot on. In total, 5 distinct messages containing links to suspect files from either updatesoftware.com and security.info were observed between January 4th and January 8th. It appears that all the phishing emails our organization received that are related to the infector.exe payload came from the same sender, Amelia Lozano at WeSellBeakers.com. Let's check on that to see if we missed anything. When querying this sender address directly, we can see 7 messages sent to our organization over a period of 5 days. Let's break that down a little bit more by examining the subject and link relationships. It looks like the sender used 3 different variants of subject and link over a period of 5 days, with a total of 7 emails sent to our organization. We can also see the notice.io domain that kicked off the triage process in the previous series. And that was just the latest part of this campaign. We now know of at least 2 machines in our environment that were compromised by this threat actor's campaigns. And we know a minimum total of 8 users that received phishing emails. Let's try and sweep for our payload using a key indicator that we identified during our investigation, infector.exe's staging directory. We observed on both 4AHX desktop and NZ6J laptop that our malicious binary was created in a very specific directory. See program data USO shared. During our investigation, we also found that infector.exe had different SHA-256 hashes on the 2 compromised hosts, which leads us to believe that sweeping for hashes may not be enough to find all the variants of the malware in our environment. Searching for the path in which we found infector.exe located in has given us multiple new files across 7 distinct machines in our environment. We notice right away that these file names for some of these files differ from our expectations. We can see svhost.exe, recordsvr.exe, and update.dll files written to the same unusual world read, write, execute path, with only svhost.exe having duplicate hashes. It seems we may have quite a few more victims than the original 2 we initially discovered. Let's pivot on the newly discovered hashes to see if we can find additional victims. We'll also create a lookup table for employee data so we can see identifiers in our results. After running this double compound query, it seems that we have as many as 8 entries for files created that match the hashes for our newly discovered malware. It seems that the folder C program data USO shared is not the only location in which the threat actor likes to stage their malware. At this point, we can determine with high confidence that we have a major intrusion in our environment that has expanded beyond the single host we discovered during our triage process. As security analysts, we have done our best to understand the scale of potentially impacted machines in our environment, and now it's time to hand that information over to the incident response team. To wrap things up, with information gained during the course of post-triage investigation, we have discovered an uncontained intrusion within our organization that likely began with a slew of phishing emails containing links to malicious files. With Gravwell, it's easy to explore our data regardless of the schema and construct meaningful queries for common investigation use cases. Today, we successfully used our findings from Triage to pivot back into our data to discover additional signs of compromise. Unfortunately, for this simulated customer, we can see that the threat actor has established a sizable beachhead. And thank you for joining us today on Down the Well with Gravwell. We hope that you're able to make the most of your newfound knowledge and harness the full potential of Gravwell thanks to the insights that you've gained today. To experience Gravwell for yourself, we invite you to explore Gravwell's Community Edition as featured in this video. This entirely complimentary version is accessible via a license request at gravwell.io/CE. It is perfect for usage at your workplace on a side project or within the comfort of your own home lab, so make sure to grab a license right away.